So the value of f of x is negative 2.5. The value of f of x, when we use the value of 1.17 in our function, that's negative 2.83, and so on. Okay, so let's evaluate our limit. So here at the left side, as our x approaches to the value of 1, the f of x approaches to negative 3. In the same way, as our x value approaches to 1, the right side table, the value of f of x approaches to negative 3 as well. Therefore, the limit of x squared minus 5x plus 4 all over x minus 1 as x approaches 1 is equal to negative 3. So another example, we will investigate limit of f of x as x approaches 4, where f of x is equal to x plus 1 if x is lesser than 4, and the quantity of x minus 4 squared plus 3 if x is greater or equal to 4. Our c here is equal to 4. Again, we will construct a table of values in left side and right side. We will construct a table of values where x is lesser than the value of 4, or to our c, but is close to it. So we will assign values of x. So here I assign 3.7, 3.85, 3.995, 3.99999. Make sure that the values of x here is in ascending order. At the right side, we will also assign the values of x, but this time greater than the value of c, which is equal to 4, but close to it. So I assign here 4.3, 4.1, 4.001, and 4.00001. Make sure that it is in descending order. Okay, next is to get the value of f of x. Notice that there is a condition here in our f of x. If x is lesser than 4, we will use the first equation. Take note that here in the left side table, all values of x is lesser than the value of 4. Therefore, we will use the first equation for all values of x or f of x here in the left side table. So we will use x plus y. Okay, so the value of f of x, if x is equal to 3.7, so x plus 1, or 3.7 plus 1, that's 4.7. 3.85 plus 1, that's 4.85. 3.995 plus 1, that's 4.995. And 3.99999 plus 1 is equal to 4.99999. Okay, to our right side table. Again, let's look back to our function. There's a condition here. If our x is greater or equal to 4, we will use the second equation. Take note, all the values of x here in the right side table is greater than 4. Therefore, we will use the second equation. So quantity of x minus 4 squared plus 3, where x is equal to 4.3, so the f of x is 3.09. If our x is 4.1, the result is 3.01. If our x is 4.001, our f of x is 3.000001. And if our x is equal to 4.00001, our f of x is 3.0000000001. Okay. Now let's determine the limits of a function. Now here at the left side, as our x approaches to the value of 4, our f of x approaches to the value of 5. Here at the right side table, as our x approaches to the value of 4, our f of x approaches to the value of 3. Take note, here at the left side, as the values of x get closer and closer to 4, the values of f of x get closer to 5. At the right side, as the values of x get closer and closer to 4, the values of f of x get closer to 3. So since the values that the f of x approaches for both sides, I mean the left side and the right side, are not equal, therefore the limit of f of x as x approaches 4 is d in a or does not exist. Again, if the values of the f of x approaches for both sides are not equal, the limit of the function as x approaches to a certain constant is d in e or does not exist. So let's take a few reminder here. Remark number 1, do not say limit of f of x as x approaches 4 equals d in e. This is wrong because d in e is not a value. D in e stands for does not exist. We should not write limit of f of x as x approaches 4 equal to d in e. Again, this is wrong. Do not put an equal sign if your answer is d in e. Okay? Next is, if x approaches c from left or through values less than c, then write limit of f of x as x approaches c negative. On the other hand, if x approaches c from the right or through values greater than c, then write limit of f of x as x approaches c positive. And furthermore, limit of f of x as x approaches c is equal to L, or the limit if and only if the limit of f of x as x approaches c negative is equal to the limit of f of x as x approaches c positive. If not, if they are not equal, we put d in e. So in the same way, in the last example, we put d in e because the limit of f of x as x approaches c negative is not equal to the limit of f of x as x approaches c positive. So these limits, the c negative and the c positive, are also called one-sided limits. So thank you for listening, class. God bless.